Hey guys. Okay, so the homework is just like super long. Um, it's not like once you kind of get the hang of it, it's still gonna be really long, but it shouldn't be the most ridiculous thing you've ever done. It just took me a long time. So anyway, I hope you're open to it. There's a whole bunch of things, equations you need to know. So instead of just giving you a really big list, I'll just go through them one at a time. So anyway, 1.1, you need to find the sum of squares total for the ANOVA. The formula for that is the sum of x squared minus g squared over capital N. So what that is they actually give you the sum of x squared, which is great, so you don't have to compute that because that would suck. And then g is given to you as well. If you don't know, g is the sum of t, which you'll get t's eventually. Don't worry about it too much. Anyway, so you're going to end up having your sum of x squared, which they give you, minus g squared, which they give you, over capital N, which they also give you. That, if you can see it. Okay, so once you have that, just go ahead, write the answer in the box, and that's the answer to number 1. Yay! Number 2, they want you to find the sum of squares within for the ANOVA. So that formula is the sum of squares of the conditions. So it sounds kind of weird. Basically, you just add up each sum of square for each sample. So since they give you 3 sum of squares, you just add them up, and that is your sum of squares for within. It's pretty straightforward. If that confuses you, don't worry about it. I mean, you just add each little sum of squares, and that's the one you use. You don't use the sum of x squared. So you just do like the poor teaching, average teaching, and good teaching, because those are the conditions, and so you add up the sum of squares of those. And then you're done with that one. So sum of squares between is well, nice thing about this homework is that the way he set it up, you figure out the sum of squares total and the sum of squares within. And sum of squares between is just the sum of squares total minus the sum of squares within. But there's also a formula for it, and I did the formulas just because I wanted to see like what would happen. So the sum of squares between SS between equals t squared over n minus g squared over capital N. And I'm just telling you that because you are going to have to use that in this homework. Not on this problem. You can just subtract the answer you found for sum of squares total, subtract the sum of squares within from that, and you'll get your sum of squares between. I'm saying sum of squares so many times. I hope it's not too confusing. So anyway, you take the answer you just found in 1.2 and subtract that from the answer you found in 1.1, and that is the answer to 1.3. Ooh, that's great. Degrees of freedom total is just capital N minus 1. So since they give you capital N, you would just subtract 1 from that, and that is your degrees of freedom total. And remember that degrees of freedom total, sum of squares total, your within and between should add up to whatever it is, whatever your total is, if that makes sense. If you have a sum of squares total being 10, and then you would have like maybe a sum of squares between being 5 and a sum of squares within being 5, and that way it would equal 10, because you can't have those two add up and be something bigger than your total, because it just doesn't make sense. So that's a good way to check if you're worried about it. If you're not worried about it, good for you, because it's not good to worry. What are the degrees of freedom within? The formula for degrees of freedom within is capital N minus K. K is how many conditions there are, or levels. So here you have poor teaching, average teaching, and good teaching. I'm not going to tell you what K is, but it's 3. I told you. K is 3. So you would take your N, capital N value, minus 3, and that is your degrees of freedom within. So then it's going to ask you, what are the degrees of freedom between? Well, you could subtract your degrees of freedom within from your degrees of freedom total, or you can just subtract 1 from k. So k minus 1 is also the formula for degrees of freedom between. So yeah, 3 minus 1 would be your degrees of freedom between. And then when you add up degrees of freedom between and degrees of freedom within, you get your degrees of freedom total. Yay! and if it doesn't add up, I might have just, I don't know. Anyway, your MS between, which I think stands for your mean, your standard deviation of means or something. I don't know. Anyway, that formula is sum of squares between over your degrees of freedom between. So, yeah, it's just your sum of squares between divided by your degrees of freedom between, which you have already found. So just do the math, and you should get a nice answer that has no decimal points. Yay! And then MS within is the sum of squares within divided by the degrees of freedom within. And then you will also get a nice answer, which mine was way smaller than the other one. I don't know. It tends to do that, at least what I was doing. And your F ratio for the ANOVA, that is your MS between divided by your MS within. So whatever your within was, oh yeah, your within is on the bottom and your between is on the top. So whatever your between is divided by your within, and that is your F point. Well, your F ratio. It's like an F ratio point. So then it wants you to calculate eta squared. I don't know how many of you were actually in class when you did this, or like were paying attention, because I know that I barely wrote it down, and I didn't think we were using it, but apparently we are. The formula for theta or eta squared is the sum of squares within divided by the sum of squares total. So if you didn't write down what those were, go back and grab them and do the math. And I got a really, well, not like a really small decimal, but it's pretty small. I don't know what you guys will get. If you get anything different, do send me a message on Facebook, because I might have done it wrong. But yeah, that's the formula for it. And the last question for number 1 is they want you to answer it with a statement. So when you're doing statements of these kind of probability statements, you need to say what kind of test it was, and then your degrees of freedom. And because we're doing F tests, you'll want to use 2 degrees of freedom. So yeah, you're going to use your within and between. You're going to say the type of test, and then you're going to say degrees of freedom between, and then degrees of freedom within. And then you're going to say what your F ratio equals, and whether or not it's a critical point, or it's beyond the critical point. So you have to calculate the F critical. And we're going to use a new table. It's called the F distribution table, and that's on Appendix B, which you can get from the homepage on Applia. So what you'll do is you'll go to the table, and on the left column there are numbers, and those numbers correlate with your degrees of freedom within. So whatever your degrees of freedom within is, go down until you find it, and then on the top are degrees of freedom between. So you choose the degrees of freedom between that you had, and then you go boop, and that's your critical value for F. And if your F value is bigger than the F critical value, then you would say that the probability of this occurring, whatever, is less than 0.05. So basically, if it's significant, because if it's significant, your F ratio is going to be bigger than your F critical, then you would say that the probability is less than 0.05. So if it's smaller, you'd say the probability is greater than 0.05.